All right, guys, we're back. Let me get the music going here. This is chill out music for work, brain power music, future garage for concentration. I don't know. All right, but the first video went over basically how to graph rational functions in this form. Okay, this honestly is not as common as the form we're going to look at next. Okay, but a lot of the same stuff is involved. So here's the form, right? We have a linear over a linear. Now this is not what all rational functions, the form of them are, but this is a good form to know, and you can apply that to everything else if you can factor. Okay, but basically, I don't know if I mentioned this before. I don't think I did, but a rational function is a ratio of two polynomials. Okay, and most of the time when you're graphing, you're going to look at polynomials that you can factor into lines. Okay, so let's get right to it. Okay, so this is something that you're supposed to look at with your graphing calculator. So if you want to pause the video and look at these three functions, graph them in Desmos, and find the asymptotes, you can. Okay, but in this one, I'm just double checking. Yeah, the horizontal asymptote is going to be 3, so that's correct. The vertical asymptote is going to be -2. Yes. Horizontal asymptote is -2. Vertical is 1/4. Yeah. 1/2 and -5/2. Yeah. Okay. Remember, when you're describing asymptotes, you want to include the variable also. Do not just write 3 or -2 or 1/2. Okay. Write the variable also. So how do we find these? Well, here's the bottom line, right, guys? For the vertical asymptote, whatever x value makes your denominator 0, that's going to be where the vertical asymptote is. Unless it factors out, it cancels with the top. Okay, so in this case, x plus 2, well, -2 makes that equal to 0. -2 also does not make the numerator 0, so that's the vertical asymptote. Here, if 4x plus 1 is equal to 0, x is 1/4, that does not make the numerator 0, so that's your vertical asymptote. And you know, when you're solving these, don't be afraid to just write out 4x minus 1 equals 0, x equals 1/4, and then you have that. Okay, no problem at all to do that. The last one, when is 2x minus 5 equals 0? That's if x is -5/2. Okay, and that doesn't make the numerator 0, so that's how you find your vertical asymptotes. Yeah, I think I just wrote it here. So if you're a memorizer, if you have cx plus d as your denominator, then the vertical asymptote is going to be at -d/c, because we would move the d over, make it negative, and then we would divide by c. Okay? For the horizontal asymptote, look what I have here, a/c. So basically what that is, guys, is the ratio of the coefficients of x. Okay? We have to be sure that both of these are linear, or they're the same degree, excuse me. But if they are, you just take the ratio a/c. Okay? So here, 3/1 is 3. That's my horizontal asymptote. This case, -8/4, that's -2. That's my horizontal asymptote. Here, 1/2, that's 1/2. That's the horizontal asymptote. Okay? And I don't want to get too much into it, guys, but basically what happens is, right, remember, the horizontal asymptote is what happens as x approaches infinity, or as x approaches -infinity. All right? So basically, these are going to be very big numbers. If that means that this dominates the numerator. Who cares about -1 if I'm dealing in the millions? And here, this dominates the denominator. Who cares about 2 if I'm dealing in millions? Okay? So really, these are the dominant terms, and you just look at their ratio to find the horizontal asymptote. Like 3 million over 1 million is basically 3. Actually, it's not even that. It's 3 million minus 1 over 1 million plus 2, which basically is 3. Okay? So that's all you have to do, right? As long as you have the same degree, and you will here, right? We have a linear and a linear. You just look at the ratio of the coefficients of the higher degree terms, which in this case are the x of the first terms. And these two, b and d, x is raised to 0. So these are the highest degree terms. Okay, so, yeah, I mean, this is just more of the same. So I'm going to go through this pretty fast. The only difference here was I had to actually compute some points, okay, compare it with the previous ones. But our equation is negative 4x over 2x plus 1. So I've got a linear. Negative 4 divided by 2 is negative 2. That's the horizontal asymptote. I drew that first, right? In the numerator, excuse me, in the denominator, 2x plus 1. Well, if that's equal to 0, x is negative a half. That's my vertical asymptote. I drew that. Okay, then I picked a couple points. I let x be 1, 0, and negative 2. When x was 1, we got this. When x was 0, we got this. When x was negative 2, we got this. Okay, and so here's the graph, right? We use those 2 points to guide the graph. If you've got a point here and here, you have to approach the asymptotes, you're done. This single point, got to approach the asymptotes, you're done. Okay, one other thing, guys, that maybe you're noticing, right? As long as this denominator is linear, at the vertical asymptote, there will always be a jump. And what I mean by a jump is the graph it flips, right? So here it was above the horizontal asymptote, and now it goes below. Okay, and the reason is, guys, what happens is as we go through negative a half, the signs change. Here all the y values are positive because this part's positive. As soon as we go across down here to like numbers that are less than negative a half, this goes negative. Okay, and that flips the sign. I hope that makes sense. Okay, so yeah, you can just get these two asymptotes. X is negative a half, y is negative 2. Plot a couple points, make the graph. Okay. Domain is everything except for negative a half. The range is everything except for negative 2. Again, I think I wrote in here the check. I set the equation equal. Never got an x value where this is true, so y can never be negative a half. All right, and then here are the asymptote statements. The limit as x goes to infinity, so I'm going to the right of the function is negative 2. We see that, right? We're going to infinity. The y values are getting closer and closer to negative 2. Okay, to the left, when x goes to negative infinity, we're going this way. X is going to, way out this way. And the y values, right, they're getting very, very close to that value of negative 2. Okay, so both of these answers, the y values are the horizontal asymptote. And then lastly, we're looking at the vertical asymptote. So the vertical asymptote is at negative a half. So I have the two cases. Remember, this means from the right. The plus means from the right. That minus means from the left. I know that looks like a 3, but that's a 2. So this is negative a half. Okay? So if I follow the graph, as I get closer and closer to negative a half from the right, what are the y values doing? Where they're getting bigger and bigger, so they're going to positive infinity. As I go to, here's negative a half, as I follow the graph, as x goes to negative a half from the left, well, I got to follow the graph, right? What are the y values doing? Well, they're going to negative infinity. Okay? So from the right, we go to positive infinity. From the left, we go to negative infinity. And again, these are the y values. This is the x value that we're looking at. Okay, I know. Last one. One more. Okay? Same thing. Find the horizontal asymptote. Negative 2 over negative 4 is positive a half. Got it? If negative 4x minus 8 is equal to 0, well, x has to be negative 2. Negative 4 times negative 2 is 8. 8 minus 8 is 0. So that's my vertical. That's the horizontal. All right? And guys, I picked some values. Right? Got the points. Here's 0, negative 1/8. Here's 1/2, 0. Here's 3, 7 over 4, made the graph. And then domain, range, and asymptotes. So I'm gonna end the video there. You can pause it and check my answers and all that. But hopefully that helps you in a little bit of a faster way go over how do I make the graph of a function that looks like this. All right, see you on the next video.